In a case of science fiction meeting reality, microscopic machines have journeyed inside a living animal for the first time. The tiny devices delivered a cargo of nanoparticles into the stomach lining of a mouse. The research by scientists at the University of California is published in the journal ACS Nano. Medical applications for micromachines include the release of drugs into specific locations within the body. But until now, they have only been tested in laboratory cell samples. Wakow and colleagues from UC, Berkeley, fed the tiny motors to mice. The machines, made of polymer tubes coated with zinc, are just 20 micrometers long, the width of a strand of human hair. In stomach acid, the zinc reacts to produce bubbles of hydrogen, which propel the machines into the lining of the stomach, where they attach. As the machines dissolve, they deliver their cargoes into the stomach tissue. The researchers say the method may offer an efficient way to deliver drugs into the stomach, to treat peptic ulcers and other illnesses. In their paper, they suggest that further work is needed to further evaluate the performance and functionalities of various man-made micromotors in living organisms. This study represents the very first step toward such a goal. The idea of molecular-scale surgery can be traced back to a lecture by celebrated physicist Richard Feynman in 1959 called "There is Plenty of Room at the Bottom." In the talk to the American Physical Society, APS, he explained, "Although it is a very wild idea, it would be interesting in surgery if you could swallow the surgeon. You put the mechanical surgeon inside the blood vessel and it goes into the heart and looks around. It finds out which valve is the faulty one and takes a little knife and slices it out." The basic idea has found its way into science fiction, including the 1966 cult classic Fantastic Voyage. Although in this case, miniaturist humans journeyed inside the body rather than tiny machines.